Tone mapping is a technique used in image processing and computer graphics to map one set of colors to another to approximate the appearance of high dynamic range images in a medium that has a more limited dynamic range. Printouts, CRT or LCD monitors, and projectors all have a limited dynamic range that is inadequate to reproduce the full range of light intensities present in natural scenes. Tone mapping addresses the problem of strong contrast reduction from the scene radiance to the displayable range while preserving the image details and color appearance important to appreciate the original scene content. Historical relevance of tone mapping. Solutions to the tone reproduction issue have been attempted since the days of early painters. These painters only had access to the limited contrast range of available pigments. Leonardo da Vinci resorted to using mid-range colors for all objects in order to attempt to achieve the desired contrast in the image, despite this distorting the actual brightness levels. 1. The introduction of film-based photography created further issues since capturing the enormous dynamic range of lighting from the real world on a chemically limited negative was very difficult. Early film developers attempted to remedy this issue by designing the film stocks and the print development systems that gave a desired S-shaped tone curve with slightly enhanced contrast in the middle range and gradually compressed highlights and shadows. 2. Photographers have also used dodging and burning to overcome the limitations of the print process. 3. The advent of digital photography gave hope for better solutions to this problem. One of the earliest algorithms employed by Land and McCann in 1971 was return X, inspired by theories of lightness perception. 4. This method is inspired by the IE-1 registered trademark S biological mechanisms of adaptation when lighting conditions are an issue. Gamut mapping algorithms were also extensively studied in the context of color printing. Computational models such as CIECAM02 or ICAM were used to predict color appearance. Despite this, if algorithms could not sufficiently map tones and colors, a skilled artist was still needed, as is the case with cinematographic movie post-processing. Computer graphic techniques capable of rendering high-contrast scenes shifted the focus from color to luminance as the main limiting factor of display devices. Several tone mapping operators were developed to map high dynamic range images to standard displays. More recently, this work has branched away from utilizing luminance to extend image contrast and towards other methods such as user-assisted image reproduction. Currently, image reproduction has shifted towards display-driven solutions since displays now possess advanced image processing algorithms that help adapt rendering of the image to viewing conditions, save power, upscale color gamut and dynamic range. Purpose and methods. The goals of tone mapping can be differently stated depending on the particular application. In some cases producing just aesthetically pleasing images is the main goal, while other applications might emphasize reproducing as many image details as possible, or maximizing the image contrast. The goal in realistic rendering applications might be to obtain a perceptual match between a real scene and a displayed image even though the display device is not able to reproduce the full range of luminance values. Various tone mapping operators have been developed in the recent years. 5. They all can be divided in two main types. Global operators, they are nonlinear functions based on the luminance and other global variables of the image. Once the optimal function has been estimated according to the particular image, every pixel in the image is mapped in the same way, independent of the value of surrounding pixels in the image. Those techniques are simple and fast, but they can cause a loss of contrast. Examples of common global tone mapping methods are contrast reduction and color inversion. Local operators, the parameters of the nonlinear function change in each pixel, according to features extracted from the surrounding parameters. In other words, the effect of the algorithm changes in each pixel according to the local features of the image. Those algorithms are more complicated than the global ones. They can show artifacts, and the output can look unrealistic, but they can provide the best performance, since human vision is mainly sensitive to local contrast. A simple example of global tone mapping filter is where VAN is the luminance of the original pixel and VAT is the luminance of the filtered pixel. This function will map the luminance band in the domain to a displayable output range of, while this filter provides a decent contrast for parts of the image with low luminance, particularly when band 0 and 0.